No, they're the same.
So you can say 1, 3, 4.
Hello and welcome back to Calculus 2, section 6.6, surface area. So this is a very quick section. We learned one formula. Calculations are very similar to 6.5. The concept is that we learned the disk method, we learned the shell method, we know that we can rotate a function around axis and get the shapes that have a circle in a base. Now, with the method, with the formula we are learning in this section, we are going to learn the formula which calculates the area of the surface of that object. So we have the disk and shell method to calculate the volume. We have the 6.5 length of the curve to calculate the outline of the object if you are to trace it on a paper, which would be the function which you are rotating, so to find the length of that curve. And now in 6.6 we are going to complete that set by figuring out the area of the shape. Now that will exclude the area of the base, but that's a circle, just run pi r squared and you can find the area of the entire object. So if your object has flat top and the flat bottom, right, then those are just circles. Over there for that cup, right, would you please model that? You would also take a look at the bottom. It's flat, right, so just calculate the diameter, cut diameter in half, r squared pi, and you are done. Now the surface area formula, we know what the area is. Area is length times the height for rectangles. And if I have a cylinder, right, which is the round object, and I wrap a paper around it, we know that the paper that I wrap around would be the rectangle, right? So the area of this cylinder would just be the 2 pi r, which is the circumference of the base times the height of the object. So for simple shapes, we really don't have to go and crank integrals and work on calculus, right? If there is a cheap way to do a problem, sure, you should use the cheap way. But then there are shapes like the bottle over there, which has curves, right? And if the shape has curves, then the shape, you will not be able to flatten its surface area into a rectangle and calculate the area. So for those kind of cases, right, you would use the formula that we are going to learn. Now, you want to know the surface area because you will be creating labels, you will be painting. Now you say, yeah, but that's not that much if you just eyeball how much paint you need. Well, yeah, for 1 or 2 items, no one cares. But if you are managing a production of 1 million items, right, and you have 10% off, well, 10% on 1 million, right, is 10% on 1 million is 100,000, right? So you're going to be 100,000 off, right? Times whatever, 50 cents. That's a lot of cat food. So it is. So you want to make sure that you have a method to calculate the area for shapes that are not straight, like cylinders and so on. So what is the formula? Well, I'm going to write the formula first and just show you, where you will immediately recognize what is the one thing that it's different. So we have surface area is equal to the 2 pi integral from a to b f of x square root of 1 plus f prime squared of x dx. So this is the formula, and the rotation over here is on x-axis, right? We see the 2 pi that gives us the curvature, so it's a round object. And then we also see that this is the area equation. It is two-dimensional, and this is technically the upgrade on your length of the curve. If I am to toss this out and toss this out, here is your length of the curve, right? Now, we know that the integral there is the length. If I multiply that by the height, the length times height gives us the area, and we just round it off. It's a very straightforward concept. We are also going to write one for the dy, right, for the y rotation. So 2 pi c to d f of y square root of 1 plus f prime squared of y dy, and that's the y rotation. Put that one here in blue, and we have our equations that calculate the area. Yes?
Are we ever going to deal with surface area of something with like a hole in it? So you wouldn't, like when you're doing the base, you wouldn't...
No, because surface area is on the surface, so you can't have a hole.
What about a donut? Like you have to account for that. Like for the paper towel thing, you have to account for the like, example you have.
We're definitely not leaving early.
So, no. Those are tougher cases, but we can work something out. I do have one of the project questions that deals with the donut, so we might sneak that on a project since you guys are interested. We'll see.
I just wanted to know how I'm going to do it.
Yeah.
Now you do have to know.
All right, so the lecture is over. I mean, that's that. Now we do examples, right? The only thing that we are introducing here is the function that multiplies the length of the curve. Length times the height is the area. So this formula does calculate the area. We know it's two-dimensional because, right, these guys cancel, integral and derivative cancel. You just have a function there, so function times function. That's area. Great. The bad news, I guess, I don't know, or good news, whatever, is that, you know, you remember this trick we had over here with the expanding and compressing and all that? Yeah, that's back, okay, in our problems for 6.6. So you might have some very easy problems, you might have those kind of problems, and now, because we have this function in front, u sub is going to have much more application as we go through problems. So let's see if we can find any of these in the homework, if this textbook ever. It keeps crashing. All right, surface area calculations. So the page that I need, which is the homework, is crashing. There it is. All right, good. Computing surface areas. So here is the surface area. Let's go with, these are all, whatever. How about, let's start something simple. No coughing. Y equals to x cubed on 0 to 1. All right. We are rotating on x-axis. You need to know that. So you have the formula up there. No pressure, 18 seconds.
What happened
It
there?
don't look good.
Oh, it did, man. Usually that's
Okay, let's take a look at this. So the surface area is going to be 2 pi integral from 0 to 1 x cubed square root of 1 plus the derivative squared. Derivative is 3y squared, so it's going to be 9y to the fourth. And then 9x, why I'm saying y, 9x dx. So derivative is 3x squared. So when you square it, you get 9x to the fourth. So this is one of the examples where you would use u sub. Very good. So u is equal to, very good. The derivative du is
36x to the third.
dx. Good. So I don't have 36, so I am going to put 36 and over 36, and that cancels to 18. So s equals pi over 18 integral. I have to change the limits, guys, because we are switching the integral to u domain, and the u domain is going to be call for u limits. So 36x cubed dx is du, so I have square root of u du. Joke, right? Plug in 0, lower limit is 1. Plug in 1, upper limit is 10. So we switched everything to u. We don't have to worry about x's anymore. We don't have to worry about converting it back.
When you plug in 0 and 1,
We plug that in the substitution equation. So when I plug in 0, this term dies, and we just have 1. When I plug in 1, 1 to the fourth is 1, so 9 plus 1 is 10. So we have pi over 18, and we have u to the 3 halves divided by 3. We put half over there, from 1 to 10. That's a 9, so pi over 27 in front. And then we have 10 to 3 halves minus 1 to 3 halves, which is just 1. And that's equal to some number. Well, if you're interested in a decimal, you will just do it. So that's one of the basic cases, and then you have the spicier cases where you have, let's say, like question 14, where your function f of x is given as the square root of 5x minus x squared. on 1 to 4. So that would be, if you have this, we first find the derivative. So f prime of x would be the derivative, so 5 minus 2x, divided by 2 times the square root of 5x minus x squared. So this is the chain rule. We had to use chain rule in this case. And now we compile the integral. So s equals 2 pi integral 1 to 4. We have the function, so that's integral 5x minus x squared, times the integral of 1 plus, and now we have 5 minus 2x divided by 2 times the square root of 5x minus x squared, everything squared dx. So I think you would agree that this is, right, a little bit more interesting to compute. I won't go that far.
You got offended? $5.
So, it's called collateral damage. I'm not concerned at all.
I'm still not upset because of $5. You owe me $5.
So 2 pi, and we have now, we have a square root times the square root. So when we have this, they merge together and the guts of the square root multiply. Hopefully, when we grind through all of that algebra there, we end up with something that we can cancel the square root with, or we end up with some kind of linear thing underneath that can be done with the basic u sub. Otherwise, we are doomed. So let's see what we get. So we have 1 to 4 integral, and then so instead of me foiling, I'm going to keep this as a unit and multiply into 1 and multiply into the second one when it's going to knock off 1 from the denominator, right? Because they're the same.
Yeah.
So when I multiply, I get 5x minus x squared. So that's the red parenthesis times 1. Plus, I have 5 minus 2x still squared divided by 4 times, and I have one of the square roots surviving, right? Because 1 is canceled and 1 survives. So I have, no, that's a lie.
What?
They all die. Because this is the square root squared, right? Square root squared. So this square root is gone when you apply the square. So it's 2 times this. This square root is combined with that square root, so it's just this coming in, and they completely cancel. See, I could have made that algebraic mistake. We're here trying to get him out of classroom as soon as possible because he... So yeah, you better. So now I have 2 pi integral 1 to 4 square root of, and we have 5x minus x squared plus 1/4, and then we do the squaring over here. That's 25 minus 20x plus 4x squared. Yes. Because we see that 1/4 and a 4x, that knocks off x squared, and you have a linear for u sub. So, yay. 2 pi integral 1 to 4 square root of, 1/4 will go in, and what do we get? So the x square and the 4x square cancel because of the quarter in front. That's negative x squared and a positive x squared. What's left? Well, we have 5x minus 20 divided by 4 is also 5x. They also cancel. Right? So technically what we are integrating is the square root of 25 over 4. Really? That's 5 halves, which you kick outside, so it becomes 5 pi integral of dx from 1 to 4, which is 15 pi, and you're done. Wow. Well, that took an unexpected turn, had everything canceled, but, you know, such is life.
Such is like.
But where do you combine the radicals, right?
When I combine the radicals, it's only the guts times the guts, right? It's called the argument.
Right. So before you, right. So on the right hand side on the same line, what happens to the denominator there?
Well, this square kills the radical,
Yeah.
and then you have this coming in, and they cancel when you multiply them completely,
Oh.
right? Because they're same thing.
So I forgot it's distributed. Yeah.
Yeah, you have to distribute. Yep.
Pretty good.
What do we owe you? We owe you.
6.7 is 6.8. Right?
Yes.
How did you cancel through like the one up on the bottom?
These ones.
Yeah, can you just like walk through that again?
So I have negative x squared.
Yeah.
I have 1/4 of 4x squared. So a quarter kills the 4. So I have a negative x squared and positive x squared. They're gone.
So the 4 just divides out of the 4.
4 divides each one, right?
Oh, and then 25 over 4 is because the quarter was left.
Yes.
And then you did everything.
So 20 divided by 4 is 5. You have positive 5x,
Yeah,
negative
yeah,
5x,
okay.
they die as well.
No, that's why I got it. Yeah.
So the only thing that is left is positive 25 over 4, whose square root is 5 halves.
Divide by 4.
Half kills 2, and you just have 5 pi integral.
I got it.
It's math, right?
So, your point. What, the homework is 6, 7, 6, 8.
Yeah.
No, that's class preps.
And then what's homework then?
The homework is already online,
6.5,
uploaded.
6.6.
Yeah, whatever we cover in class, that's the
I don't do
homework.
the online one.
That's okay.
Wait, we didn't
Whatever.
have to think.
All right, guys. See you tomorrow.